Hello little Pingus men, I'm DD Thinker and today we are going to learn about philosophy, more specifically what is called metaphysics or what I call phenomenal philosophy, where phenomenal philosophy means philosophy of phenomena. There are certain universal principles which describe the phenomena and happenings of the universe, in which in phenomenal philosophy, general aspects of what the universe is like can be investigated, such as space, time, the self, and the environment. In this video I'll be discussing what the environment is like and the universal principles of how environmental phenomena behave and can be understood. Phenomena of the environment often can be observed to collect and progress towards stable states. This is thanks to matter behaving in ways that see the convergence and progression of matter towards certain states where the behavior of matter can be ascribed perhaps to physics and chemistry. Dust progresses via settling down, such as on windowsills when things are stable. Chemicals progress towards stable states in chemical reactions, bringing unstable reactants, the chemicals that initially exist, to stable products, the chemicals that exist finally. Genes progress towards being fit and efficient to the organism's survival through natural selection, bringing about a stable state. Finally, ideas also progress in a similar manner to genes, towards being efficient and useful for the human individual, where ideas collect and are refined in the mind, often reaching a stable state. Dust which settles, chemicals which form products, genes which become fit, and ideas which become efficient, all display with a certain type of progression, evolution if you will, towards stable states. This natural progression and evolution of matter towards stable states can inspire a pretty principle which I call the SS principle, with SS being an abbreviation of structure selection. This principle of structure selection can be stated in the following. The world is populated by stable structures, with unstable structures being eliminated in deselection and stable structures remaining preserved in selection. For example, chemicals which settle and progress towards stable configurations of stable end products through chemical reactions reach stable states which can be said to be selected compared to unstable chemicals which are deselected. Natural selection also sees this progression towards stable states of fit organisms being selected and unfit organisms being eliminated in deselection. Ultimately, this SS principle can apply to many phenomena, in which it was first promulgated by a lovable atheist friend, Richard Dawkins, in his book The Selfish Gene, where he first recognized natural selection is actually a manifestation of a more general law, which I've now dubbed and given the name the SS principle, which sees the selection of structure in general. The late Daniel Dennett also saw the importance of these observations and realized they could apply to describing many phenomena. And another rather foolish fellow who spent 20 years bashing his head against a wall, trying to force a solution to his theory while not bothering to investigate the broader picture, named Mr. D.B. Kelly, nevertheless realized the true importance of these ideas, which have been termed universal Darwinism by others, and what I call my theory of structure selection. This SS principle can also be characterized similarly to natural selection's survival of the fittest, as being the survival of the stable, or what I prefer to call the collecting of the stable. Dust collects to be stable, chemicals collect to be stable, genes collect to be stable, and ideas collect to be stable. The descriptive power of the SS principle, i.e. collecting of the stable, is highly generalizable and can characterize much phenomena, so it's very useful from a philosophical perspective. Another snazzy and descriptively useful concept is what I call selectional equilibrium. When anything, such as structures, reach stable states, I call such a state a selectional equilibrium, which is similar and related to the concept of thermodynamic equilibrium. In thermodynamic equilibrium, things are in balance, such as can be seen in heat being uniformly spread at thermal equilibrium, things having reached a state of rest and mechanical equilibrium, chemical reactions being stable or having stopped in chemical equilibrium, and radiation seeing no change and is at radiative equilibrium. Back when I was 18, I felt thermodynamic equilibrium could characterize structure selection in general. But the concept of selectional equilibrium is more broader than thermodynamic equilibrium, and can characterize any system that has reached stability disregarding physically measurable aspects. For example, economic equilibrium, like thermodynamic equilibrium, is an example of selectional equilibrium, in which in economic equilibrium, supply and demand are in a state of balance, and price and quantity of goods and services are unchanging. For instance, the price of apples and their quantity is unchanging due to stable market forces. Selectional equilibrium is therefore when any structure reaches stable selected states. Along with selectional equilibrium, yet another poopy idea is the idea of settling. In settling, as per how you've probably used the word yourself, things settle down after a while. Many things can be said to settle down and reach stable states along with species settling down in natural selection into stable fit configurations of adaptations. In the process of settling, things are initially in chaotic states in which over time many semi-stable things exist for brief periods of time before transforming into more stable, longer-lived structures. An example of this can be seen in leaves in a windy courtyard, which collect into stable configurations in nooks and crannies out of the way of the wind. Species also reach stable configurations in fit adaptations to their habitat. Just as leaves find stable configurations in nooks and crannies, so does species find stable configurations of fit adaptations. Examples of settling can also be seen in ecological succession, seeing an ecosystem approach a stable state through successive stages, the early internet settling and having websites rise to prominence, and a person settling down and living in a new house. To conclude, unless you're a literal worm, these ideas of selectional equilibrium and settling are pretty simple to understand. And like a worm, you'd think it's trivial, but no, it's actually both foundational and unstated, in which having a rigorously understood description of how things can be best characterized is very important from a phenomenal philosophical perspective. An important example can be seen in the hypothetical scenario of stuffing hamsters up your butthole. Hamsters are known as cute pets, so they're very useful for stuffing up your butt. In darker previous times when most people were dopey chumps, people didn't know what things to stuff up their butt. Who would lose their car keys up their ass? I mean, what sort of pleb does that? But nowadays, as things have settled, evolved, and reached selectional equilibrium, people have transitioned towards more cultured and sophisticated tastes as supermen who have vast wisdom and know that hamsters truly are the best thing to stuff up your ass. In it goes! There are various absolutely bitchin' examples of the applications of the SS principle that you'd want to open your butthole to. The first example, Lizard Boy number 1, can be seen in cosmology, where matter within the universe has settled down and reached stable state since the Big Bang, which was initially chaotic and unstable, however has transformed into a stable state. Matter within the universe collects towards stability per the SS principle collecting of the stable. The second example, Man Sausage number 2, can be seen in astronomy, where matter settles and collects into celestial bodies where it is stable via gravitation bringing matter together, in which other applications in astronomy can be seen in stable orbits of celestial bodies, which can have stable orbits that are undisturbed by other bodies and may see what is called resonance in orbits, where specific orbital configurations are stable, and also in stars where there is an equilibrium between internal forces and may ultimately transform and collect into more stable white dwarfs or other such end states for stars. Celestial bodies, orbits, and the matter within stars collect into stable configurations per the SS principle collecting of the stable. The third example, Numberino 3, can be seen in thermodynamics, which as I've described previously, sees various equilibria of thermal, mechanical, chemical, and radiative equilibria, which can be related to selectional equilibrium and the SS principle, where matter collects into stable configurations that see the collecting of the stable. The fourth example, Skinny Penis number 4, can be seen in chemistry, where chemicals seek to attain and collect a full outer shell of electrons by gaining or losing electrons, which is a stable configuration which collects over time. Electron configuration stability can be seen in ionic and covalent bonding, which seeks to attain and collect the stable configuration of electrons, where ionic bonding transfers electrons while covalent bonding shares electrons. Also in chemistry, energy determines bonding, in which bonding is made stable to energy, such as in exothermic reactions, which release energy, and endothermic reactions, which absorb energy. Finally, in chemistry, chemical equilibria can see specific quantities of chemicals collect in a dynamic equilibrium of chemical reactions and reach and collect to a stable state. Electron configuration, bonding with energy, and chemical equilibrium are seen in chemical reactions which bring about stable configurations, which sees collecting of the stable, where unstable reactants transform into stable products. The fifth example, Stinky Dinky number 5, can be seen in nuclear physics where nuclides, which are types of atomic nuclei, have stability and exist and collect primarily on the belt of stability. Various nuclear reactions, analogous to chemical reactions, see the transformation of unstable configurations to stable configurations through processes like alpha, beta, and gamma decay, in which it is in accordance with the SS principle of collecting of the stable. The sixth example, Bohr number 6, can be seen in particle physics, where subatomic particles have a range of stability and can decay into more stable particles. Ordinary matter, which is observable, like electrons, protons, and neutrons, are stable compared to other types of particles. The seventh example, Lucky Ducky number 7, can be seen in earth sciences, where the structures of Earth collect and reach stable states. This can be seen in landscapes which change and reach stable states over time, such as via erosion, weathering, and such. The eighth example, Endless Hoheism number 8, can be seen in biology, where various biological structures reach stable states, like adaptations and their genes being selected and collecting to habitats, and genes selecting the environment and gene expression. In gene expression, genes make the environment stable to them, which occurs via gene expression transforming various chemicals, food, into useful and fit structures of the organism. Genes are selected to be stable to the environment in natural selection, and the environment is made stable to genes in gene expression, as per collecting of the stable of the SS principle. The ninth and final example, Becker number 9, can be seen in artificial structures, where various nervous system and computational structures reach stable states in a similar manner to biological structures. Ideas in the mind are selected and collected to be stable to the environment and sensation, where senses such as the eyes change ideas to the environment, and the environment is made stable to the ideas in the mind via muscles, which sees the transformation of the world to be in accordance to ideas such as seen in civilization's various structures, from cities to the smallest economic products being a result of collecting of the stable to humans. Ideas are selected to be stable to the environment via senses, and the environment is made stable to ideas via muscles. Throughout cosmology, astronomy, thermodynamics, chemistry, nuclear physics, particle physics, earth sciences, life sciences, and human sciences, the SS principle and collecting of the stable can apply as a unifying description of the origin of structure in general in my theory of structure selection. Simply looking around you, from the structures in the sky that are mega huge to earthly structures and down to the smallest teeny tiny structures, all the structures surrounding you have collected into their configurations due to their stability. The SS principle is so pervasive in describing phenomena that it could characterize time itself in what is called the arrow of time, in which entropy increases. However, the thermodynamic concept of entropy is not as fundamental as the SS principle. In this video, I've talked with verbal diarrhea about some of the basics of my theory of structure selection. I first discussed the SS principle, which can be characterized by the phrase collecting of the stable, which states, the world is populated by stable structures, with unstable structures being eliminated in deselection, and stable structures remaining preserved in selection. After the SS principle, I discussed the concept of selectional equilibrium, which can describe various different types of stable equilibrium states structures can converge to, along with the concept of settling. Finally, I discussed the applicability of the SS principle, which applies the SS principle throughout physics, chemistry, biology, and human sciences. These ideas, which are universal ways of characterizing phenomena, belong to my newly defined field of phenomenal philosophy, i.e. the philosophy of phenomena, and are useful at describing general ways of how various structures, or in my opinion, all structures, can be understood, progress, and behave. Although simple structures can be understood simply by the SS principle, various complex structures, as seen in biological and artificial structures, are dictated by more sophisticated principles which relate to another concept I call agencies. With these further principles of complex structures, I feel my theory of structure selection provides a synthesis and unification of many phenomena with only a few principles. The power of natural selection in biology is generalized to all types of structures in my theory of structure selection, be them natural or artificial, in the SS principle. Structure selection explains the origin of structure in general, and as such it is mega important. If you're interested in my other ideas, they are of similar quality to these and I have a lot of them. My other ideas will be presented on this channel going forward, so if you're interested in them, you can smack that subscribe button and right the bell for notifications. Alternatively to my channel, I've written some texts which I've prepared. The first text is an accessible introduction and sample of my ideas and talks about the questions we don't ask, and presents some fundamental questions which are relevant for any actor, such as yourself, in the cosmos. This first text is called Hiding in Plain Sight, the questions we don't ask, and is on the forum Less Wrong, which I've linked in the description of this video. The second text is my magnum opus, Whack 11, which exhaustively compiles all my ideas and is written in a special way which utilizes a technique I call frameworks. The technique of frameworks is ultimately a way of organizing pieces of knowledge in lists, in which it is comparable to Nick Bostrom's recent papers. Whack 11 is best read on a PC given its frameworks require a wide screen, and I've also linked it in the description of this video. In regard to my situation and why I'm presenting you my ideas, I'm an amateur thinker who is wishing to popularize and spread my original ideas that I've made by myself, and I'm also outside the intellectual community. Given my situation, I would firstly like to ask for feedback, which you can do in the comments, where you can also ask any questions you have of my theories. And secondly, I would like to ask for you to contribute to spreading my ideas, which you can do by sharing my video to those who might find my ideas interesting, or merely by liking the video to tell the algorithm that you liked it. Anyway, thanks for watching, nerds. Bye bye!